All right. I guess you can still hear me, right?
Yeah.
Okay. So, like I was saying, we are going to be tackling IP addresses or IP addresses. Okay. So I mentioned that they are more of like the host addresses that you have, or more like your phone number. Okay. So, but in networking, we have it in this way. It looks like this. It is 4 numbers that are divided by 3 periods. So each of these we call that we call that an octet. So it can look something like this. It's a very popular kind of IP address. You might have seen it before, maybe on your Wi-Fi or somewhere that you saw something like that. It could be there, or it could even look like this address here, 127.0.0.1, which is the classic address where there's a loop. There's even a meme about it. Like there's no place like 127.0.0.1, which is like the PC's loopback address, just to say that it's the home address of that person. Okay, so this is how an IP address looks like, and each of these numbers that are separated by the dots is a group of 8 bits. Okay, so normally we call that an octet. So this over here is a full octet. This over here is another octet in that order, right? So this is what we call the IP version 4 address, right? But there are some few details that I'll just mention, which you probably wouldn't have to worry about if you don't want to, but it's something good that you have to know. There are different classes of IP addresses. Okay, so we have class A, class B, and class C. Those are the ones that we usually use for network connections. Okay, so um, we have class A, class B, and then we also have class C, right? So for all of these, they have like where they start and where they end. So it's very good for you to know when or like where they start and when they end. So from here, what I'm going to say is that you see, I was saying that we work or we call them octets. So there's the first octet, second octet, third, and fourth. So with the class A, the first octet starts anywhere from 1 till 126, right? The in other documents you might see 127, but 127 is reserved for the loopback. So refrain from saying it goes up to that side. So from 1 to 126, if you see any IP address that is starting from 1 to 126, it is within the class A IP addresses. Okay. Then with the class B, what it does is that it continues from where this one ends. But then also remember that the 127 is still reserved. So any IP address that starts with 127 is reserved for the machine itself. It doesn't go anywhere. It's just on that same system. So this one starts 128 all the way to 191. Okay, so any IP address that you see starting from 128 all the way to 191 is in the class B IP address class, or yeah, the class B. Then the class C, it starts from 192 all the way to 223. Okay. So there are other ones, class D and class E. The class D is used for multicasting. That is when you are trying to send something from one place to a multiple group, or like a group of people at the same time. So I think that will make me have to mention these terms. We have unicast, and then you also have multicast. There are other ones as well. There's also anycast, right? So we will just focus on the unicast and the multicast. So the unicast is when I'm sending something from one PC to another PC. So basically from one person to the other person. And the multicast is something like this. Okay, so to use an example in the WhatsApp that we use, right? So if I'm sending a message directly to someone in their DM, I'm sending a unicast message. It's just for that person. But then let's say when I needed to tell everyone that there's going to be a session, I had to send it out into a group, right? So I was sending it from one point to multiple people. So in networking, we usually call that a multicast. So from one place to another, or like from one place to a group of devices. Okay, so that the multicast also has its own set of IP address
Maxwell,
range.
sorry for the interruption. Sorry, I think some persons are raising their hands. I don't know. I think two
Um,
persons.
again.
Actually, I think someone is raising his hand. I am seeing like two hands up.
All right. Yeah. So like I was saying, most of the this one here is not. I can't see the board. Okay. So please Okay. So let me Jakarta. You good. You good. You go first since your hand is up first. Um. Yeah. Can you say something? Hillary, I see your hand up too.
Okay, good evening, Max.
Yeah. Good evening.
Okay, from the classes, from the IP classes, class A starts from 1 to 126,
Yes.
but apparently class B starts from 128. What of 127?
Yeah, so I was saying that the address that starts from 127 or the 127 first octet number is reserved for the PC. It's used for the loopback address. Basically, the loopback address is the address that the system uses for itself. So anything starting with 127 is for the system itself. So we don't really use it. We don't really assign this to any PC. Every system comes with this address by default. Right. So if you ping your PC with 127.0.0.1, it's going to ping itself, or it's going to test connection to itself. Okay. So we don't. This 127 is not really, let's say, be part of a specific class because we don't really use it. Okay, so I just left it out just so that we probably wouldn't mix it up. So normally this is, or these are the valid ranges for the classes that we have. You see, I didn't even start from zero. There's a network that is 0.0.0.0, but we don't assign that. Okay, so for the ones that we assign, they are the ones within these ranges that I've written over here.
Okay, thank you.
Right, sure. I see yeah, okay, so I guess this one can be solved within the background as I check it out. Okay, so also in the meantime, what you can do is you can go to all right, no problem. So whilst you are joining, just allow the browser to use your microphone. Okay, so now that we know these IP addresses, right? So like the classes, this is what we call the classful IP addressing. Right. So everything I said about one starting from 1 to 126, and the other starting from 128 to 121, and all of these like this. There's also another concept that I'd like you to note, right? There's also the classful subnets, right? So the subnets are what determines what kind of network we have. So these ones, I'll just put them here. You can check them out if you are interested in learning more about them. For Class A IP addresses, or for the Class A, what it has is this kind of subnet map. So the subnet map is what gives us the hint that this is what is for the network and this is what is for the host. Okay, so by what I mean by the host and the network is that you see when we talk about the IP address, and there's a portion for the host and then the portion for the network. So at times, like let's say you see your phone numbers, there's a portion of it that belongs to the telecommunication and then one that belongs to yourself. So the one that belongs to the telecommunication is the one for the network, and the one that belongs to you is the one for the host, if I should say. Right. So let's say a typical number in Ghana will look something like this. Let's say 055 123 4 5 6 7. Hopefully that's 10, right? So there are 10 numbers here, right? So this first three over here belongs to the network, but everything here belongs to that person. So this is the real number of that person. This one here is just for the network, right? So this one is how we know which network the person is on. Okay, so in networking we have that same thing, just a little bit different. And these are also something with bits that we are manipulating. We are just saying that, well, this number of bits belongs to this, right? So here we have 8 bits all turned on. That's how we get the 255. So whenever you see something over here like this, it's just trying to say that all the bits here are turned on for the network. So nothing should go to this side. Okay, so I'm just trying to keep it as simple as possible. But for now, let's not really worry about the details yet. Then the class B has this subnet mask. And you would probably also assume that since it's following a pattern, then class C should also have this subnet mask. So usually you will see IP addresses within this range. Okay, but then for each of these addresses, or for each of these subnets, there are the number of IP addresses that we can use. So the 000 over there is for the hosts, or basically saying that this much of addresses can be used for the host side, right? Meaning that we can create this number of hosts. And like I mentioned in the beginning, this is bits. So here is 8 bits, another 8 bits, another 8 bits. So that is saying that 2 raised to the power, that is going to be 24 bits for the host. So meaning that 2 raised to the power 24 minus 1. Usually we do that, but that is not something that we really have to worry about. But just saying that this much bits can be used to create hosts. So meaning that on a network, you can have 2 raised to the power 24 devices. Okay, but it is mostly unrealistic that we are going to have that much addresses in one place. Okay, so also for this one, we have 2 raised to the power 16 addresses that we can assign for the devices. The network has already taken the first 16. And this year, we also have just 8 bits for the host. So meaning 2 raised to the power 8, right? And this is going to be the most common network that you find used by your routers or your phones, or like the class C is the most utilized for, let's say, home office environment. Okay, so I just wanted to point this one out. But if you're interested in learning more about networking, you can go more into that and understand that, right? So whenever you see an IP address starting with this range, you know what class it's coming from. But that does not mean that every time you see it, that's what it means. There's also something called CIDR, right? Classless interdomain routing, which is something that I wouldn't want to go into. But that came to sort of scrap this Classful thing that we just talked about, right? So these things over here are static, meaning that class A has to use this, class B has to use this, and class C has to use this. So for every time, if I'm having a class C, I can only have up to 254 pieces, right? And also for the class B, that's somewhere around 65,000 plus or something like that. And then for class A, you can look that up, is into the millions or so. Okay, so for the classless, what it does is the one that you see something like, let's say you see an IP address like 192.168.1.1/24. Okay, so this slash 24 over here, whenever you see it, just think of it in terms of bits that are turned on. So is it the same thing? It just means that for this IP address here, 24 bits has been turned on for the network side. Okay, so still using this example, the network side is what belongs to the network, and the other side you have is the one for the host. So whenever you see things like this, it's simply to do 32 minus the number of bit mask, or the number of like the number that you see over here, right? So I mentioned that each of this is an octet, meaning there are 8 bits. So 8 times 4, we sorry. If we do like our math, we can see that, right? I hope that's clear for everyone. I mean, we have 8, like we have 4 8 bits, right? 8 plus 8 is 16, and another 16. So 16 plus 16, that's going to be 32. So if you have something like this, or if you are looking at something like this, that means that you are just going to do 32 minus 24, and you find that it's the answer you'd get is 8, right? So meaning that we have 8 bits for the host. Okay. So just to confirm that you are getting what I'm saying so far, let's do this. Okay, so let's say that I have an IP address starting, well, let's say I have an IP address of this range. Let's say 12.1.1.40, right? So if I have an IP address like this, which class am I on? Like which class would I be in at this point? You can unmute yourself and then say again. At A, right? Okay. So this one here happens to be in class A because you are within the range over here. So what's going to be the default subnet mask for an IP address within this range?
255.0.0.0.
Right. Okay. So that's how this will look like. Okay. So this also the same thing as I've been saying, right? So I'll just let's do a quick primer on the bits thing, but we really wouldn't go much into it. So here I have 8 1 bit that have been set. That's why I have this value. Okay, so I think I have something here that I would like to share. Let me bring that up. All right, I have something. Hopefully, I still have it here. Oops, all right. I'll get that during the course of the meeting, and probably I'll share that at the end. Yeah. So let's check something out here. Okay. So I'm saying that for this 255, it just means that we have 8 bits that has been turned on. Okay. So give me a minute. Just trying to get the thing. Okay. So I'm just getting it off my hard drive, and I'll share that. Okay. So
can anyone hear me?
Yes, I can hear you now. Okay, so this
Sorry.
yeah, I can hear you. All right. So I'll just try to bring this up real quick. Oh, come on. All right. So what would happen is I would have to do a few fixes. Sorry about that. Just give me a moment. Let me just get something real quick. I always type my password wrongly. Give me a moment. I would have to grab it up from the external hard drive, and it's in a Windows format, and it always has a way of pissing me off. All right, so let's see first. All right. Okay. All right. So let's check it out. I think I have some information here that will be useful. It's yeah. All right. So I could share this with you if you like to learn more on IP addressing, but for now that will be like we wouldn't really go into that. All right. But here I just have something on IP addressing, or like sorry, bit manipulation. Let's just say it's just like on binary, right? So here let's just look at something. Hopefully it's clear for you to see. All right, so I would assume that you can see that. So here I have the like something like a binary to decimal calculator, and then a binary to decimal calculator done in Excel. So here we have 255. So if I write 255 here, you can see that all the ones are turned on, right? In the same way, if I change it to, let's say, something else, it's going to be that. And I mentioned that the class A starts from 1 to someplace. Okay, and like we wouldn't go into the math and all of those things yet. So you can see that 0 is all zeros in binary. If I have something, just to make it know that it's working, right? Like the binary versions are working. Okay, so when we have something also like this one over here, it just means that 8 binary bits have been turned on. Okay, so this 255 here means that out of the 32 bits that we have, 8 of it has been allocated for the network. Okay, so that means that the network has been saved for that, and that is how we come about the slash notation. So for this kind of IP address here, we can say it is /8, just to say that it is going to be within this subnet. Okay, so if you see this kind of number somewhere, that is how you calculate it. Okay, so if you had seen 12, right? So if you had seen 12, that means that we have 8, and then we added 4 more. Okay, so we can just say that we have 8, and then we added 4 more, right? So that's going to look something like this. If we should put that into binary, so there's going to be a quick binary session, and then we get back to the other side. So this one just to help break things down. I'll add spaces in between each 4 binary ones to make it easier to read. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, right? And then the rest are all zeros. So 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0. Okay, so basically what we are very much interested in is this 12 over here, like these bits that have been turned on, right? And one thing that you should know is that in the subnet mask, the ones have to be contiguous. We can have the ones scattered across. They will always be contiguous in this kind of way. Okay, so if we have something like this, all right, it just means that the first 8 bits have been taken away from the network, and then we took 4 more bits for that. So that's how we got the 12 bit mask. Okay, so is someone saying something?
Yeah, I have a question.
All right.
Okay, so sorry, I'm taking you back. Or I was following until my mic started misbehaving. It got to the point where you were trying to classify the IP addresses into, there was one you said classful ABC, and then I understood everything from 1 to 126, and you said 127 is reserved. I understood that, but when you started explaining subnets, that was when I wanted to ask a question, but I didn't follow from that period. I've been trying to work on my mic since then.
All right. Sorry about that. Okay, so for the subnets, I was trying to say, or related to the fact that we have phone numbers, and then some parts of the phone number tell us where or like which part of the number belongs to us and which part belongs to the telecommunication company. Okay, so for instance, here I was given an example of a typical Ghanaian phone number where this side, sorry, this side over here, it's a typical for the person owning the, like the, let's say, this is a person's phone number. All right. And then this is a side for the telco, let's say the telco extension, if we should put it that way, right? So this number over here tells us which number it's or which telecommunication company this number belongs to. Okay.
Sorry,
so,
does this telco extension include the country code of the person?
okay, so I'm just trying to keep it to what belongs to the network itself. I'm not talking about the country code or that at all. Right. So this is just like what the telecommunication company itself will give you as their, like their extension, not about the full country-based thing. Right. So in Ghana, like the numbers start from 0, then the telecommunications next 2 numbers. All right. So we have 055, we have 026. I'm talking base in Ghana. All right. So that's what we have over here. So this part of the number tells you which network you are using, and then the rest of it is the one for you. All right. So I was saying that for the classful IP addresses, they also have something like that called subnets. So the subnets tell us which part of the network, or sorry, which part of the IP address is the network, and then which parts of the network, or sorry, of the IP address is for the hosts. Hosts meaning that like the laptop you are using, the phone you are using, anything that can have an IP address, that's called a host. Okay, so the subnet over here is similar to, let's say, the 055 here. So for, let's say, for here, the first 3 numbers belong to the telecommunication. But let's say we live in a weird world, let's say in Ghana, and then for some reason the first 6 numbers rather became the one for the telecommunication. It would have looked something like that. So the subnet is just a way that we are able to group or to distinguish which part belongs to who. Okay, so that's what I was trying to say over here. It's just a way to determine who owns which parts of the phone number or the IP address in this case. Is that clear?
Yeah, this part is clear. Well, the other part where you started explaining 2 raised to power something, 2 raised to power this, you talked about each being an octet, and I don't know if you can maybe a little bit.
All right, so I was just saying that as part of this here, like the subnet mask for the classful IP addresses, when we see the 255 or wherever the bit is set over there, we can use it for host addressing. So let's say that you see currently, if I have 255.255.0.0.0, right, it just expands to this in binary. It just means that the first octet that I have is all ones, right? 8 binary ones will give you the 255. Okay, so this 255 here is just meaning that all of these have been reserved for the network, so we can't touch this. But everything from here all the way to this side, all the zeros can be manipulated to create network devices, or like to create valid IP addresses for host devices. So this over here sums up to 24 bits that we can use. So since it is binary, I'm saying that 2 raised to the power 24 minus 2 can be used to allocate IP addresses for devices on the network, right? But I was saying that we wouldn't really go into why that is the case. I was just trying to point out that that is what is happening. If maybe later you'd want to go more into networking, you can check that out and understand more of that, right? But I'm just saying that if you see this much, that's what it means, that for the first 8 bits or for the first octet, that has been taken for the hosts, sorry, like the network. So we can't touch it, or we can't create host addresses from that side. It means that that part of the bits or that part of the network cannot be touched. Everything that is a 0 can then be modified, okay, to create something else. All right, so that's the same thing for the 255 or 255. That means that the first 2 octets have been turned on, meaning we are only left with the next.
The last thing.
Yeah, so that's what it's just saying. So for the number of bits that are not turned on, basically the zeros, those are the ones that we can use to create devices on the network. Okay, so the more zeros we have, the more hosts we can have on the network. The lesser hosts we can have. So for the classful hosts, sorry, for the classful subnet and the IP addresses, these are their default subnet masks, right? So they determine how many IP addresses we can have on a network, right? But I was saying that there's also a different way of representing this same thing, the 255 or 255.0. Basically, when we break this into the binary representation, you can see that 8 bits are the ones that are turned on. So we have the slash notation where we can just say that, okay, well, for this, it is a /8, meaning that only 8 bits have been turned on. And if we convert that to binary, or sorry, into decimal, we will have this. So that's a way that we can either like represent it either in this subnet mask notation. We call this the dotted decimal notation. Right. That's how we call this one. And then usually this one, you can call it the slash notation, but then it's actually something that came across with the CIDR notation. And I said that this CIDR just means classless interdomain routing, and something that we wouldn't go much into. But it's a way that we are able to, let's say, go around the classful thing, right? Let's say I want to use an IP address in the range 1 and 126, but I don't want to use this kind of subnet mask, because think about it. We have 3 zeros, meaning that we have 24 octets that we can use for IP addressing. If we should do this mathematically, if I do 2 raised to the power 24, you can see the number of IP addresses that we can have. It's impractical that at a particular location, this number of devices will be there. So this classless interdomain routing is a way that we can manipulate the bit so that we can say that, okay, well, I would like to shift it to some parts, right? So it just means that I'm going to borrow some bits from the host portion and add it to the network so that like I can have more networks and let's say fewer hosts, or I can balance things out. But this is, let's say, going to be network specific, and I wouldn't want to go into that since it's not going to be something that we are going to be mostly interested in as software people. But if you want to know more about that, you should look into routes into networking. So that's what I was just trying to say. So if you find an IP address that has a slash notation over here, like the /24, it just means that 24 bits has been turned on, or there are 24 ones. That, yeah. So the same is true. Let's say if we have 29, is the same. It means that 29 bits have been turned on, and they have an implication on what it happens to the network.
So this
Like,
20, when they say 29 bits have been turned on, that's from the network end. It's contiguous to the end, right?
exactly.
It's not like, okay.
Yeah. So that's what that means. So if you convert that into decimal, then you get a dotted decimal notation, right? So you can either see it this way, or you can see it in this other way, right? But for example, in this network that I have here, I have essentially just written it in the slash notation because it's easier to write and it's like cleaner, like just to put it this way. Okay. So if you see an IP address, something like this, that's what they are trying to say. Okay. So I brought this up because we are going to be using this, and we are going to be seeing IP addresses as we go about. And I'd like to be asking you which default range you think it would be inside of. And in the world today, hardly would you find someone using a classful IP addressing. Usually, we use something called subnetting to break the network into smaller portions, so that we don't have to have a very large network with a large number of hosts. We break it down into, let's say, smaller components or subnets. That's how we call them, basically smaller divisions. So I think
Sorry,
that they are, yeah, come again.
yeah, it's like you're trying to explain the difference between the classful and the classful subnets.
No. I'm saying that the classful IP addressing. Okay, so here, like the classful over here is actually not complete. I'm saying there's a classful IP address range, right? That's what really it is. And then for the classful address range, there's also the default subnet mask that they have. Okay, so the addresses starting from like, so I'm just trying to say that for every address that is in the class A, it has a default subnet mask of this. Then there's like that, right? So I'm not saying that these two are in, let's say, very much difference. They work hand in hand. Okay, so I'm just saying that any IP address that starts with 1 belongs to the class A. Same for class B and class C. That's how they start. Okay, so by how they start, I'm talking about the first octet, like the very first number that is, right? So that's what I'm just trying to put across over here. Okay, so that's
And you said that class C is usually the most commonly used, right?
Yeah, mostly. If you check your IP address right now, you find it somewhere within that range.
Okay. Any particular reason?
Yeah, because you see, for let me just bring up the calculator one more time. So you see that the class C has only 8 bits left for host addressing. That means that we have to raise to the power 8, right? And usually we do -2 because there's the address for the network and then address for the a broadcast domain. A broadcast address, which I really don't want to talk about because we don't have to worry about that for now, right? So that means that on a class C network, we can have up to 254 devices, which makes sense. right? That in a particular setting, you can have, let's say, up to 254. Because think about it, if you are buying a router for your house, you don't even have up to 30 devices at your home, right? So this address over here is usually better because the number of IP addresses that you can assign is not very large. But if we should check the same thing for class, let's say B, which gives us up to 16 bit for the host portion, you can see the IP addresses that we can have. It doesn't make sense that a person would have this much.
65,000.
Exactly. Right. So that's the reason why normally class C is used in home routers and those kind of things. Yeah. But there's more to this, which we wouldn't have much time to talk about. All right. So we've broken down a bit of the networking side. We've seen the classes of IP addresses that we can have, and keep this in mind because when we start like analyzing some packets, I'll bring it back and then ask you what is the default network range that you think this is going to be in, okay? And then just to be poking around with your mind a bit. Okay, so that'll be all for the network, for the IP addressing part. If you're interested in this over here, I could share that. Also, I have, you're saying?
Yeah, I have another question.
Okay.
So, like, I tried on my system while doing the task, I tried to ping gov.com, but it refused to ping on my system.
All right. So there could be a number of reasons, and we are going to talk about DNS today, which is the service that allows for those kind of things. So we will talk about that and see some of the other issues. So if you have a question around DNS, HTTP, HTTPS, Telnet, SSH, ICMP, or anything relating to ping, you can hold on for that. We will be talking about those things next. But does anyone have a question regarding what we've talked about up to this point with regards to the IP address classes and their default ranges and their default subnet, as well as that? So I also mentioned unicast and multicast, something that you probably want to keep in mind. For any cast, I would suggest you look it up, but it's not something very crazy. But I'm just trying to be on the things that we might need for now.
Another question.
All right.
So because they said IP addresses are unique to systems, right? Like just like everybody has a unique phone number.
Yes.
So now, why is it that the IP address of the local host is always 127.0.0.1 for every local host?
Yeah, that's what I was saying, that this is reserved, so everyone uses it. It's for the system, so it's like a global thing, right? So the IP addresses, yes, they are unique to each device. That is for the ones that I just mentioned over here. But for the ones that I've not mentioned over here, you can find them used by multiple devices. And even the ones that I mentioned over here, there are other subcomponents within them that I've not talked about, right? Which I would mention that soon. But this 127 over here is reserved for everyone to use, right? It's for everyone to use. That's how the PC knows how to get back to itself. And we call that a loopback because usually in networking, when we are trying to figure out whether our network stack is working, we ping ourselves because which other way is better to confirm you have a valid network card than pinging yourself to see whether you can reach yourself, right? So that's what it is used for. Every PC can use it. That's its usefulness actually. So yeah, that's all. Yeah. So the final thing I would like to mention over here is something to do with public and private IP addresses. Okay, so we have public and private IP addressing. So let's just go through that for a while. So out of the usual ranges that we have, all right, so here we have, let's start with the private IP addresses. All right, so for the class A, okay, so I've already mentioned the full range of the class A, B, and C. All right, but then within this range, we have some that is allocated for use by local machines, meaning that these IP addresses are not seen on the internet. Okay, and then there's also the one that are used on the internet. Okay, so as your PC is going out on the internet, it's not using your 192.168 thing. It is transformed, but for now, we'll get to that point. So this over here, the class A, what it does is that any IP address starting from 10 dot anything, a private class A address. Okay, so though I mentioned that class A start from that, any IP address that is starting from 10 dot anything is a private IP address in the class A range. And the class B over here, it also has another range, which is over here. That it starts from 172.16 dot anything all the way to 172, I think 31. Yeah, I think so. Dot x, right? So anywhere from 172 to 31, right? So sorry, 172.16 all the way to 172.31 is reserved for private IP addresses. So by private IP addresses, like I mentioned, they are the ones that you are using on your PC at this point, because IP addresses are very expensive. So these ones are the ones that have been allocated for our use. There are other IP addresses that before you can use them, you would have to buy them, right? So these ones here are the ones for our usages locally. Then the class C has this one. That is why you would see this often, right? We have 192.168. So any class or any IP address that you see that is within 192.168 dot anything is a private IP address. It's not used on the internet. It can't go on the internet, right? So these are the private IP addressing. Anything else you've not seen over here is a public IP address. Okay, so if I have something like 192.169, it is a public IP address. Okay, so everything not within this range is not an IP address. Sorry, is not a private IP address. And there's one more that I would like to mention, just so that you will see it, right? So there's one here that is it starts with what do I have here? 169.254 dot anything. Okay, this one over here, Windows call it AppPaper, right? I can't seem to remember the full one. I think it's automatic private IP address something. Yeah, automatic private IP address, something like that. Automatic private IP address. Yeah, that's it. So this IP address over here is allocated whenever a PC is not able to reach out to something we call a DHCP server to allocate it an IP address. You see that on your phone or on your laptop, right when you connect to your router or anything, you don't think about it. You just receive internet connection. But then it was because we were able to receive an IP address within any of this range. That's why you are able to go out on the internet. But let's say something happens and then you're not able to reach the server which would give out the IP addresses, you are going to receive something
like when your data is finishes and then you try to accept something and then something comes like this.
Not exactly. That one is a different thing. This one is for the cases where you are not able to reach an IP like a valid let's say a valid DHCP server. I'll try to show that if there's time, right? That's how Windows calls it. I think that's automatic. I think automatic
Private IP address.
Yeah, private IP address. But you can look it up. That's what I think it is because yeah, I think so. And but then other systems call it something different, and can't seem to recall that on top of my head. But yeah, you are going to get this IP address if you're not able to reach a DHCP server, and a DHCP server is what hands out these addresses, right? So that's some of the things that we just had to know. All right, so if you are looking at your IP address and it is within this range, 169.254, forget about going onto the internet. It can go on the internet, like, or forget about, let's say, talking to other people on the same network that you are on, right? At least for this one, if you have any of this IP address and you have a bad connection, the connection can be fixed and you would have a good network or like access to the internet. But this one over here, it cannot go outside of its network. Like it can't go anywhere. Okay, so there's just something. And most of the things I'm just saying here are things that you can go back and read up on, right? I'm just trying to bring them up as we go. Okay, so now let's see, any questions so far about the private IP addressing, right? And then the or anything we've discussed so far. Could you you can bring up your questions, because from here we are going to dive into the lab network and we are going to like check out the things as they fly by on the network. All right. So any questions so far?
Yes, Max. I'm still wondering why a private IP address will not be used on the network.
Come again.
I'm actually wondering why a private IP will not be used on a network.
All right. So what I was saying is that it is used on a network, but it's just not used on the internet. Okay. So none of the websites that you visit have an IP address within this range. These IP addresses are for human use, or let's not say human use. Like they are used for, let's say, in-house. It's not used on the internet. Okay. So for your device on the, like your laptop, your computer, those devices, they are going to have an IP address over here, and this is how we build networks. All right. So if you enter any company right now, they are having an IP address within these ranges. But to go out onto the internet, they actually have to buy an IP address within the the public range. Okay. So on our local network, you can use this one. This one is for free. But if you have to go outside onto the internet, people are in charge of handing out IP addresses. They sell it, right? So you would have to buy that IP address together. Imagine having to buy an IP address for each person on the like in the company. It wouldn't be enough at all. Like I think one thing that I didn't mention is that for the IPv4 address here, we are only limited to 32 bits. And if you remember, if we do 2 raised to the power 32 here, we have only about 4 billion. And if you know the population of the world at this point, we are more than that. So each person on the face of the earth right now cannot buy their own IP address, even if they wanted to. Okay, so that is why this IP address range has been given. I can use 192.168.1.1, and you can use the same thing at your home. Nothing will happen, right? So the fact that IP addresses are unique to the host that they are using, or like the host that is on, let's say there's a little bit discussion on that, right? But yeah, when we are talking about public IP addressing, they are all unique. Or when we are talking about IP address on a particular network, it's unique. But then for these private IP addresses, anyone can use it wherever they
I have
are.
a question.
Right. Okay.
Okay, so now I have a private address. Let's say I'm using my system and it has data. I bought data and I'm using it to work. Now, I now decide to connect my phone to my system, to the data on my system through a Wi-Fi. Now, the question is, that's the connection I made through from my system to my phone. How will it's a LAN, right? It's a LAN connection. But the connection I now made from my laptop to directly to the, what's it called? To the internet. What's it called?
All right, I'm coming. I'm just trying to put something together. Oops. So here's my cloud just for this sake. So this is, let's say, your PC, right?
Yes.
Okay. Then let's say you connect to, let's say, modem, right?
Okay, yeah, PC directly to the modem that gave me the data, yeah.
Okay. So usually there's like this kind of router somewhere over there. Right? So like let's say within your local network you are given an IP address, let's say like .100. This one for your PC, right?
Okay.
So if you are trying to go out onto the internet, this IP address here is not accepted on the internet. So this router over here would take care of changing it. Like it would send a different thing, or like let's go ahead. So when you send an traffic which needs to go outside of the router's interface, let's say like it didn't go anywhere on your own network, but it has to go outside of your network. What would happen is that this router over here will do something called network address translation. It will translate your private IP address into a public IP address. So let's assume that in our company, we have an IP address that has been bought by the company, and then the address is 2.2.2.2. Remember that 22222 is within a class A, and it is a public IP address. So the router over here would change your IP address over here like this. If you change it to 2.2.2.2, send it onto the internet. So like a router will be impersonating you. It will behave as if it sent the connection. And the good thing is that, which we'll get to, based on the application you use to send the connection. And yesterday I was saying that application doesn't mean the browser you are using. It is the protocol that you use.
Sure.
Let's say you are are you saying something?
No, you stop for a moment.
All right. So I was saying that when you're going out onto the internet, your PC sends out the connection to the router. Like the job of the router is to send network that is meant for someone outside your environment. Like that's what it does. It takes packets or requests that is not within your environment and then sends it there, let's say from your PC to the internet. So now this over here, let's assume that that is a IP address that our company has bought. So this router over here would change this IP address that you have. It would make it into, or to make it look like this before sending it out onto the internet, right? So on the internet, this is what it sees. It sees 2.2.2.2, not your 192.168.1.100. That's not what the internet sees. And the good thing about this is that, as I was saying yesterday, we have applications, protocols that we will use. So let's assume that you are going onto the internet. So whilst you are going onto the internet, there's, let's say, this is an example of how your IP address would have been looking. Let's say you are going from your IP address, which is 192.168. Let's assume that the internet is using 40, okay, 40.40.40.40 for ease of saying it sake. Right. So yesterday I also mentioned that the combination of an IP address and a port number is called a socket. So let's say we are trying to go onto the internet, and we understand that port 80 is for the internet, right? So we are trying to go to the IP address 40.40.40.40, which is hosting a web server, right? And yesterday I didn't really mention it, but I asked that you look it up. But the port numbers that you are going to use is going to be within a specific range, which is called the ephemeral port numbers. For the sake of this one, I'll just say our port number is 1234. Okay, so when your connection, let's say, builds up, is going to look something like this from your network, or like from your PC, and that's what your router is going to see. But because 192.168, this is not allowed on the internet, what is going to happen is that your browser, sorry, your router is going to do this. It's going to change this part of the address, then make it, sorry, it's going to do something like this.
222 dots.
Yeah.
Okay, the 1234 will remain. That's the ports of this thing.
Well, not exactly, but I'm just putting it there for the ease of explanation, right? But like the router does some sort of mapping to know who sent it and how to get back to it. So now this is what the router will send. So the server on the internet is going to reply to this IP address. So when the reply is coming back, your router knows that this connection was what initiated this. So when your router is replying, it will take off this IP address and then put yours back and then send it back to you. That's what happens back and forth when you are browsing the internet. You send something, the browser changes it into a public IP address, sends it there, brings it back to you back and forth using the concept of the sockets, right? And these are things that you probably have to check out, but it's mostly within networking or heavily taught in networking.
Quick question.
All right. So now that we are, let's say, okay with this, we're going to have a look at some few things. All right. So the concept that I talked about here is what is called a NAT. Right? It's called NAT, network address translation. You can look that up if you are interested in learning more. Okay, so that'll be it for this one here. Okay, so I mentioned that we are going to be talking about some few
pinging
protocols. Yes. So the first one that we will start with is what we are all used to. We always go to the internet and then type something and expect that it should work. Of course, it should work. So here's what happens. Let's say, so I just have something here like the browser, right? So I'll just double click that. And what happens is that, okay, so I'll just bring it up here and then I think, yes. So I'll go to my Firefox, right? It's a browser that we all know, right? So usually what I'll do is I'll just go to something like, let's say facebook.com. So when I say facebook.com, I'm expecting that Facebook will show up, right? But I mean, they are saying that the browser is unsupported, which is, let's say, bad news. But anyway, I mean, like this is actually just for example's sake. So rather, let's go to google.com since Google will not bail on us. Yeah, Google is very fine. So you can see that though like the Facebook was telling us that the browser is outdated, it still works. Okay, so you see, something happened for this to work. Like something is really happening in the background for this to work. Okay, so that is what we call the DNS, and the DNS is what allows us to do things like this. Okay, so we are going to look at how DNS is working, what port it's using, and maybe what can go wrong and how we can look it up and fix it. So it's going to be quick so that we can look at the other ones as well. Okay, so here's what happens. Whenever we type in like google.com, for example, so what I'll do is first I'll close this out. And then the other thing I'll do here is on my network here, I can capture traffic. Okay, so what I'll do is I'll right click it and then I'll just say start capture. Okay, and then I'll just say okay. Then our focus right now is on DNS. So over here, I can apply a filter. I would increase it a little bit. Okay, so I'll apply a filter called DNS. That's what we are trying to like handle at this point. So now what I'll do here is that I'll come to the terminal, right? So here, what I can do is a few things, right? But this box over here might probably be limited. So let's go back to the Firefox browser. All right, so we'll be, hey, I have to move it from this side. Okay, so we are going to be doing that, and you can see even just at this point we have lots of DNS stuff going on, right?
So what did you type again?
Okay, so currently I have not typed anything, but the thing is that while the system is even running, things are going on in the background. So it could be one of those things, right? You can see there are quite a few things here that I didn't do myself, but the system did it, right?
I don't how are you able to locate that page that started bringing all this thing? Can I do it from my end?
Oh, well, if you download Wireshark, you can do that.
Okay.
But it's an application that I have here. It's normally used for network analysis and those things.
Okay.
So now what I'll do is I'll go to let's say www.google.com. Right. So I'll just do that. Okay. So now what I'd like you to see is that currently we are on number 292. Okay, and these are all valid like DNS request. But then what I would like to do is to start everything from scratch, just so that we don't have to worry about the one that has been there already. So I'll stop it and then I'll start another one. All right, so hopefully we wouldn't have any extra DNS stuff. So then I'll press the enter key over here. Okay, so now you can see that just by doing just that, like I just type google.com, just google.com, right? And just google.com here has brought up all of these things. And currently, if I should highlight all of these, that's going up to 330 plus stuff. But let's take a look at it now. All right, so let's start from the top. Okay, so here, this is what is happening. I would like to show my IP address first. So yes, if I do an ifconfig here, you can see that my IP address on this system is 192.168.122.210. Okay, and then my default gateway, that is the IP address of my router, is this. It's 192.168.122.1. Okay, and the DNS that I'm using is the same as my like my default gateway. So I can confirm that by doing something like cat etc hosts file, right? So here I probably don't see that, but there's another command that we can use. But for now, let's hold on to that. Let's go to this side and then look at this for a while. So you can see that here I'm sending the thing from my computer. This is a source, and this is my destination. Okay, so I am sending it from here to my default gateway. So that is what I'm using as the destination to get to wherever I want to get to. It could have been something different, but that's what we are using here. And then here I'm making a query to google.com. Okay, so I send a request for the IP address of Google. If you see this A over here, it means the IPv4 address. If you see the quad A or the 4 A's, it means the IPv6 address, but that wouldn't be something that we worry about, right? So here is a query. There's also another query from my PC to that side. And then now I receive the response from the server that responded, right? So let's start from the top again. So here, what we are interested in is a few things. We are going to be looking at these two places, this place and this place, right? What you should also know is a protocol that these services are using. So DNS uses the UDP, okay? So it's called the user datagram protocol, which I'm sure you've probably seen at this point. And then there's also the TCP, which we will see shortly, right? So it uses a port number of 53. This port number is a well-known port number for DNS service. Okay, so when you see a port of 53, that's for DNS. Okay, so let's step into the query and look at what we were asking for. So that's what we are trying to ask for. In the queries, we are asking for who is google.com, right? And we are asking for like the host address. That's what we are trying to get. Okay, and in Wireshark, it makes it so easier that I could just see where I was responded to. So I asked for something, and if there was a server that can reply back to me, I'll get the reply. So here I can go to the 14 packets, and then I can see that there was a response. Okay, so in the response, I have these answers there. So it says that the IP address of Google is 216.58.223.228. Before anything else, what IP address range is this here?
Sorry, come again.
Yeah, what IP address range is this? Like, is it class A, B, or C?
It's in class A.
Class C.
Class C. Okay, so another follow-up question: is this private or public? Do you remember
I'm not sure. It's public.
Okay, so do you remember the ranges that we mentioned? I'm saying that here, if you have any IP address starting from 10, is a private class A address, and this is for the class B, this for class C. Anything else that I didn't mention here is a public IP address, and I can't list all of them. So yeah, so that IP address over there with what you know now, is it a public or a private IP address?
It's a public.
Public IP address. Great. So we can see that to go out on the internet, Google is using a public IP address. It's not using one of these 192 or like 192.168 or any of the private IP addresses that we were talking about. You can see a couple of other DNS requests that were sent. Right, so we have another one sent to Google. Right, so this is like what happens. But then at times when we send out some things and the server doesn't know how to respond, well, it doesn't give us anything. Okay, and since
I
this
have a
is
question.
going to be okay.
Like what you just did now, is it the same thing as typing ping google.com on a terminal?
Not exactly. Ping uses a different protocol, which we will get to. But the thing is that anytime you have a name that has to be resolved, right? So, for example, here, if you have my number and you're going to call me, right? You go to your contact and look for my number, right? Or you are going to look for my name, right? So when you call my name, you're actually calling my number, right? But then on the internet, what we work with are these numbers. But since it's harder to remember a number than a name, we have names attached to these numbers. So Google is actually at this IP address, the one that we saw. Oops.
No, what I mean is I can actually ping the IP address of Google, and I'll still not get the. Okay, the question is this now: if I ping my local host IP, it gives me a response, but whenever I ping the IP address of Google, it doesn't give me what I'm expecting. That's the question. The question I'm trying to ask.
Okay, do you ping the IP address of Google or do you ping the DNS name of Google?
The DNS name.
Yeah, so okay, so this is what I'm trying to ask. Do you do something like let's say you do ping google.com or you ping the IP address of Google?
Yeah, I've done ping google.com. It didn't work. Like it showed me after when I put enter, the next thing that followed was Google's IP address, and then it started hanging. Then when I now did Control C, it now told me that maybe 100 signals were sent, 100 lost, something like that.
Yeah.
Well, if I do the same for my local host, I will get nothing lost, something like that.
Yeah, like your local host is your source code. So if that doesn't work, then you have a problem with your network card. Yeah. So that could be a number of issues.
Is it from my
Right.
end?
So,
Like I missed it for like 30 seconds.
it depends. Right. So for that, I can't be sure unless we do some like test around and figure out what the. But if you ping 8.8.8, you receive anything back?
Let me try it now. I don't think I receive. The only thing that gives me response is my local host. Let me try it now.
Yep.
You can
Yeah,
continue.
but I'm trying to say that usually when you're trying to ping a DNS name and you're having some issues, usually we recommend trying to ping the IP address if you know it, right? And there are other ways of doing that. Okay, so since we are still here, right? Whenever you are, let's say, let's say probably you are working with DNS stuff and you're having issues. Let me use a different device. So here I have this one over here.
Okay. Ping 8.8 is working.
Okay, then we can assume that it's a DNS issue. Okay, so now I'm bringing up my this over here, right? So now, whenever we are working with DNS, right? So I can do ping google.com, but when I do ping google.com, anytime I do something that has a name inside of it, first of all, DNS has to kick in, and that's what we just saw, right? So anytime you are using a DNS name, it has to be resolved first to get the name, sorry, to get the IP address so that it can ping it or it can do whatever it needs to do with it. Okay. So
sorry. Can you hear me?
yes.
Yeah, it's now working. Even pinggoogle.com is now working. Well, previously when I tried this, it wasn't working.
All right, that's fine. Sometimes it will take a while to, let's say, come back, or there was a lot of lagging going on, or probably some issues with the network. Right. So yeah. Okay. So we have less time to continue. So let's go over something. So now, like I was saying, every time that you are working with a DNS name or a name in particular to networking, that name has to be resolved first before anything else can be done. So if the name resolution fails, you can't go onto the internet. So sometimes it's not really the fact that your network is slow, it's the fact that the DNS server or the the means to resolve the name to what you are trying to use took so long that it makes the network lag. But most of the time we blame DNS for that. Okay, but it's not always that. So sometimes you have to check. So let's say that we are trying to work with Google and then something is going wrong. Okay, so first of all, what I'll do is I'll just ping for the first time just to show you that it's working. So I'll ping Google for 3 times. So I'll ping google.com for 3 times. All right, so I'm pinging this. You can see that this IP address that I have here is somewhat different from what I saw when I did the capture on the other device. You see, here I'm using 216.58.209.78. And let's check for this one. It looks a little bit different. 216.58.223.228. See that it's sort of not really like that, but that doesn't mean that it's not Google. It's still Google, just that Google has a lot of IP addresses that or a lot of servers that have been allocated to handle traffic, right? So based on the one that it receives it first, that's the one that you are going to see its IP address. Right? So now, let's say that you're working with your device and then maybe you are having issues with like the internet or and you want to figure out whether it's going all right, you can do something called an NS lookup, right? So a name server lookup. So I can say NS lookup google.com. So what is going to do is, oops, Okay, quick one. Let me just do that. I thought I had that installed. Oops. Give me 2 seconds. So I'm using a Docker machine in my lab environment, and then it looks like that command is not available. So let's see if I can install that real quick. Hopefully that's the name of the package. Give me a moment. Let me just find it real quick.
Sorry, that 8.8.8.8. What IP address is it?
Is the Google DNS server.
Okay.
Oops. I can't seem to remember like how to get this up. Okay, so let's see. Install. Nah. Give me a moment. Let me try to get this up. Okay, so just for the sake of time, let me rather use something that will give me the result I need. All right, so I will use the Windows PC for this. Okay, so there's this command called ns lookup. Okay, so ns lookup, and then I can have google.com, right? So here, this is what it does. It's able to go on the internet and then tell me that, okay, well, Google is at this IP address, right? And I'm using a server, like the server that I'm using is this over here, like this, okay? But then if you're on Windows, you can do something like this. You can do ns lookup, then you can say, let's say dash /8. Oops, sorry. Nope. Quick one. Let me. Not sure. Let me just step into that, and then yeah. So what you can do is you can actually set the server name or the way that you want it to be. So you can either do it interactively, or you could write it directly from the command prompt. So I'll go into it interactively, and then let's do that. Oops. Okay. So here, what I'll do is I'll just say that the server is 8.8.8, right? So this is going to be the server that I want to use for that, right? So that is the IP address for Google's DNS server. So now I can do something like, well, I would like to find google.com, right? So now I can see that the server that I'm using is 8.8.8.8, and there's a response I'm getting. Also, I can do something like twitter.com, right? So here you can see that for everything I'm doing, I'm receiving the results as is expected. But sometimes, let's say when you are trying to do something and it's not returning anything, then there's some kind of an issue going on. Okay, so that's something that you would have to check out and figure out. So if you are trying to ping something and it's not working, and the ns lookup is not returning anything useful to you, then you can assume that something is wrong with your DNS server. So you can either change your, you can either try a different DNS server, or maybe just have to wait for the DNS server to come up. So some of the popular ones you can also have is one that is this 1.1.1. So either the DNS server of Google, or 1.1.1.1, which is from Cloudflare, right? So that's also one that you can try out. Okay, so we would look at this one, and then end for today, so that we can
Wow, the NS lookup is working on my system.
Yeah, that's okay. Yeah, so on mine it's
I'm
a Docker
using,
machine, so like the
okay.
things are limited. Yeah, so I had to install that, but I thought it was one of my other PCs, like other virtual PCs, but then it wasn't.
So
So
when,
yeah,
when I did twitter.com, it showed me 8.8.8 as server. Then address, it now said 8.8.8.8 hash 53. The hash 53 is what?
that's the port number that it's using. You remember that I said that DNS uses port 53, port number 53.
Okay.
Yeah, yeah. So there are a few things that we couldn't talk about, but you can check them out. Maybe another time we can figure those on. There's SSH, HTTP, and HTTPS. There's Telnet, and then ICMP. ICMP is used for the ping command. There's also the trace route command that I would ask that you check it out. All right, but
Sorry.
yeah. Any questions?
Yes. Sorry, I just want to know because in the morning when I was trying this thing, I did I first of all did ping google.com, ping 8.8 blah blah blah. It didn't work. But I thought it was my network, and then I went to my Chrome browser and I did google.com. It worked. I didn't have any issues. Like, is there what could have been the problem? Because now it's working perfectly. I'm not having any problem.
Yeah.
I was
Well,
actually thinking it was from my
it
terminal.
could it could be a number of things. Either maybe at that particular point in time, the part that it was using wasn't replying as fast as possible, or like it could be just that like there was a lag, the server wasn't responding early. So without a specific analysis or let's say capture on what was happening at that particular point, we can't really be sure on what was
Okay.
wrong. But
Probably
then it could
next time
be
I'll
the
screenshot
fact
it.
that
Yeah.
yeah, well, like the screenshot alone wouldn't really help us, right? You see that
Okay.
there's this over here that I use to analyze things. So here is not only used for showing the port numbers and things. We use it for actual analysis on networks. So for something like this, I can see that you sent it from here to there, and how long it took for it to respond, and things like that. Okay. So for example, here you can see that I have something like this. I sent it at this particular point in time, and then the response came back around this time, right? So for something like that, I can see like the time in between when you sent it and the time you received it. Okay, so from there I can be making a conclusion that okay, well, it took the server this much to respond, and this is why it did that, or things like that. So that's how we could have been able to deduce what the issue was. But it could have been multiple issues, whether at that point the connection you were having wasn't very strong, or the server just wasn't replying early, or there was just something in between that was causing a problem to happen. So, like I was saying, there's this command called it's on Windows. It's called traceset, right? So when you do this over here, it shows you all the steps it takes from your PC to wherever you are going, right? So here I can see that first of all, it goes to my router, which is the first one. Then there's another router in between. It goes through all these routers so that it can get to a particular point, right? So meaning that from my PC over here, like from this Windows PC, these are the steps that I'm having to go through to get all the way to google.com. Okay, so sometimes for things like this, that's what happens. And you can see the time that it's taking each of these to respond. So sometimes the response time could be very long, and that's what is going to cause the issue of the network lagging. All right. So sometimes these are the ways that we are able to figure out, okay, well, it took it this much. That was why I was doing that. Was it DNS or was it that or was it that? So it could be different issues. Okay, so it took 16 steps to get to google.com, and within that 16 steps, one didn't really work, so it had to use a different path, right? So okay, actually two didn't really work well. So when it doesn't work, it has to find a different way to get to that same place. So sometimes, let's say there's a lot of timeouts, all right, but we can discuss that more at a separate time.
Okay.
Mark,
All right.
those,
Any last question?
Hilary, are you
points
saying
that
something?
yeah, those points that you're referring to paths.
Come again.
Those points that you are referring to as paths.
Paths. Oh, yeah.
Yes.
Yeah. These things. Yes.
Yeah. Can you elaborate more? Are they servers or what?
Okay. Well, not necessarily servers. Actually, the last thing that you hit is an actual server, right? But anything within it, they are, let's say, routers, right? So on the internet, probably have to show something. I don't have a network like that at this point, but like on the internet, there are, okay. Let me try to see. Let's say yeah, an enterprise network, right? Just to show something, right? So on the internet, there are a few things that happens. Let's say well, maybe probably not the best example yet, but by paths I mean that like, think of it like I'm moving from my house to wherever Google's server is. So from my house to wherever Google server is, that's the path I'm using. Okay, I think I can use this as an example. Okay, so you can see that, let's say you don't worry about the connections and everything here, but say for example that I'm trying to go to Google server. Okay, well, here's a web server here, so let's use it. So from my PC here, right, I'll have to go out to my PC, like from my router, right? This is my first router on my network. This one has to take it. That's the first hop, or the first part. Then, thankfully for this network, right after I move to the next one, because this router knows where to send it, because it has been configured to know how to do it. It will send it to this one, and this router will find out that, oh, okay, well, the server that he's trying to get to is directly attached to me. So from here, I'll go from 1 and 2, and I'll get to that side. But then in this case, we because the internet is a vast place, it had to go through vast number of routers. So that's what I mean by the parts. Okay, so it moves from one place to the other. Yeah.
Okay, thank you.
Just last question, please.
Yeah, go ahead.
Okay, sorry. So while I was reading about this network ports and all that, they said, is it, yeah, TCP, that's Transmission Control Protocol, that
Yes.
it's lower, it checks for errors and it sends and then it receives. But on the other hand, UDP is faster. It doesn't check for error. That's why it's faster. It just moves directly, just like your online game. If another person, because of network, is unable to join, the game will continue. So, while I tried downloading something today, and for some reason it was hanging, right? I wanted to test what I learned. So for some reason it was hanging. So what I had to do was to shut it down, like properly, like I had to shut down the process. I was thinking that, okay, maybe if I now restart the system and maybe click on that, it will continue from where it stopped, since it uses what's it called? I think TCP now. Yeah, it uses TCP now. That's in downloading. Downloading is TCP, right?
Mostly, yes.
Yeah. So, but I've been finding it difficult to continue the download. So that is just on the side. I just so let me ask.
Start from the beginning again, right?
It started from what I observed was that it started from the beginning, but that place I stopped before, that was where it continued. Like,
so it continued from
let's
where
say
you
I stopped
ended.
at 50. Yes, let's say I stopped at 50%. When I now maybe shut my system, put it on back, when I did that thing, it started from that 50% to progress.
Okay. So you paused it, or you actually canceled it?
I canceled it totally. Like, the thing was hanging. It was really, really hanging. I just wanted to.
Okay, so either there's a mechanism that is allowing it to like continue from where it paused at a particular point, right? So that's one reason why that could be happening, because the thing here is that with a TCP, it keeps sessions. So probably that's one of the reasons why it was able to do that. Okay, so
Okay.
yeah.
All right.
But
Thank
then, like
you.
you said, the UDP doesn't really keep them. It's like, for example, here, if I'm talking and then you don't hear me, whatever I said goes by, or
It's
like the
lost,
game
yeah.
example that you gave
Yeah.
is also valid. Yeah. So I would have to end on this note, right? And we could try to check out the other ones maybe at a later time, but. Thank you for turning out, and
thank you for your
that'll
time.
be everything for now.
Thank you.
I will end the session.
Okay. See you tomorrow.